Part B. So graphing and finding zeros of a polynomial function. These are the steps that we follow. If the polynomial isn't factored, we're going to factor it using steps from Part A. 2, we're going to use what's called the zero product property, and it's just stating that when something's set to equal to 0, we can use inverse operations and solve for that unknown. But we're going to do that to set each factor equal to 0. Oh, wait, that's not what the zero product factor property is. Zero product property is telling us that if one number is 0, then it makes the whole problem 0 when multiplied. I don't know what I just told you. Those are your x-intercepts. So those would be our x-intercept. That's our x comma 0. Hit y or set equal to 0. Okay. Then we're going to find our y-intercept by substituting x equals 0 into the original. And so then we'll have our 0 comma our y. Okay. Then we're going to choose x values in between the x-intercepts and substitute in and find the y values of those. This is just to help us have a more accurate graph. Then we're going to plot all the points and use the end behavior to determine the start and end of the graph. End behavior things, remember, is if it's an even power, even positive, that we're going to be going up and up. Okay, sorry, even power, we're going to be going up and up. Okay, if it's an even odd, then an even negative, even odd, it's going to be going down, down. If it's an odd plus, remember, that means that we end positively, so we have to start negatively. And if it's an odd negative, that means we end negatively, so we have to start positive. Okay, let's dive in. So here we have, what are the zeros of f of x equals x plus 2, x minus 1, x minus 3, graph the function. Well, step 1 says to check to make sure that it's factored. Well, look at that, check. It is factored already, boom, 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 okay? Step 2 says to take each factor and set them equal to 0. So we have x plus 2 equals 0, we have x minus 1 equals 0, and we have x minus 3 equals 0. And we're going to solve for x. So we have x equals negative 2, so I have an x-intercept, negative 2, comma 0. We have x equals 1, so I have an x-intercept at 1, comma 0. And we have x equals 3, so we have an intercept at 3, comma 0. Okay, hopefully you're still with me. You feel pretty good about this. Now we're on step 3. I was like, what are we? Step 3 is to find the y-intercept. And that says we're going to let x equals 0 in the original. So we have f of 0 equals 0 plus 2, 0 minus 1, 0 minus 3, which gives us 2 times negative 1 times negative 3, which equals 2 times positive 3, which is 6. So our y-intercept is at 0, comma 6. All right, step 4 says we're going to choose points in between our x-intercept. So we have right now, where we're at negative 2, 0, negative 2, 0, we're at 1, 0, we're at 3, 0, that's not clear. Okay, we're at 3, 0. And then our y-intercept is at 0, 6. So I'm going to choose values before and after my y-intercept. So like if I first value, I can choose, let's do -1. We're going to find f of negative 1, which equals negative 1 plus 2 times negative 1 minus 1 times negative 1 minus 3, which equals 1 times negative 2 times negative 4, which equals 8. So at negative 1, I'm at 8. 1, 2, 3, 4, 5, 6, 7, 8. And then let's do 2, f of 2. So we have 2 plus 2 times 2 minus 1 times 2 minus 3 equals 4 times 1 times negative 1 equals negative 4. So I'm going to go to 2, put down 4. And there's that. Okay. I could do it on the outsides. I could do negative 4 next, and then negative 3 next. So if I did f of negative 3, plug that in. I have, and it's, in all honesty, it's kind of easier to substitute when it's in factored form. So negative 3 plus 2, negative 3 minus 1, negative 3 minus 3. That's going to give me negative 1, negative 4, negative 6, and that gives me 24. So it's a little off, but here we're going. Step 5 is to use all of this to graph in our end behavior. So the end behavior here, if this was in polynomial form, what would it be? Well, I can find my leading term by multiplying all of these x's. So my leading term would have to be x to the third. And each one of them have a positive 1, so it'll be 1x to the third. So I know I have an odd positive. Because of that, I know that it has to start negatively and end positively. So tracing my dots, I'm going to start from the bottom left. That's not good. Start from the bottom left. I'm going to go. I hope you know. I don't know why. It's like worse than normal right now. Goodness gracious. Great balls of fire. Let's try that. Like my hand in my eye. I promise I'm looking at the screen. But we are not on the same page. Okay. We're gonna let this be one for the books, and oh my goodness, hopefully yours is better than that. But yes, so this is the wavy version of what the graph would look like. Okay. So here on example 4, I would like for you to take a moment and pause and go through the 5 steps on your own in order to graph this. All right, welcome back. Thank you for participating. So step 1 is to make sure it's factored. Check. Step 2 is to take each factor set equal to 0 and find your x-intercept of x equals 0. So 0, 0. We have x minus 3 equals 0. That gives us x equals 3, which gives us 3, 0. And then we have x plus 5 equals 0. That gives us x equals negative 5. So we're at negative 5, 0. Okay. Step 3 is to identify your y-intercept. So your y-intercept is when you're looking for f of 0. So if I plug 0 in, it equals 0. And that makes sense because it's at our origin. Oh my gosh, mind blown. Okay. Step 4 is to choose values in between your x-intercepts to find accurate, a little more, make it a little more accurate. So we're at 0, 0. We are at 3, 0. We are at negative 5, 0. So I'm going to choose a point in between. So I'm going to go with a value in between. I'm going to do -3. I'm going to do f of -3 equals -3 times -3 minus 3 times -3 plus 5. That gives me -3 times -6. So a lot. Times 2. And that equals 36. What kind of gives that? All right, let's choose a number between here. Let's do 1. F of +1. So I have 1. Plug that in. 1 minus 3. 1 plus 5. That equals -2 times 6, which equals -12. So I have f1 equals -12, and I have f of -3 equals 36. I think I can count by 6. I can count by 6s. 4s may not make it. 4, 8, 12, 16, 20, 24, 28. Yeah, we won't make it. So we're counting by 6s. So each one of these for me is going to be a 6. And this is a -6. So I need to plot on my x-axis. This is 0, 0. Already done. I need my y-intercept. My y-intercept is done. And I need just to put 36 in -12. So at -3, I'm going to go up 6 spaces because I counted by 10, 6, 12, 18, 24, 30, 36. All right. And then I need -12 at 1. So at 1, I'm going to go down -6, -12. And now I'm going to connect. And there we go. So notice that this time I didn't have to really analyze the behavior, but if I was to analyze it in behavior, instead of just following my points, I would see that I have x times x times x. Again, I would end up with odd, positive. So I'd have to end positively, start here, negatively. All right.